Now that we know how to represent a molecule as a chemical formula, another really common tool that we use, especially in the lab, when we're trying to weigh specific amounts and plan reactions, is to use the atomic mass of the molecule or the ionic compound um, to help us figure out how many of a molecule we have when we have a certain mass of something. So I want to show you how to calculate that because it uses the two things that we've learned so far. It uses the periodic table and it uses the chemical formula. The example I'm going to use is another one of our solvents that we use in the cannabis industry a lot, carbon dioxide. We also walked through all the different ways of representing carbon dioxide. And so here I have its name and its chemical formula, CO2. So with the chemical formula and the periodic table, we can figure out what the mass of each atom in the molecule is, and then just add them together. And then that's the mass of the molecule, right? So it's kind of like if I have a Lego that weighs 1 gram and I put 3 Legos together, now I have something that has 3 grams. Basic principle. So let's take this element by element. So let's start with carbon. So C is for carbon. What I'm going to do in these cases is I'm going to go over to a periodic table. I'm just going to, scooch this over here. And my carbon is right here. And it has an atomic mass of 12.011. Remember, atomic mass is usually the number that has all the decimal places. The smaller number, that's a whole number, represents the atomic number, and it's the number of protons that the element has. So this is, and the units for this number are atomic mass units when we're calculating the mass of just one molecule. If we were calculating the mass of lots of molecules, we would use grams per mole. So we're going to use this one right now. All right, so we have, there we go. So our carbon has a mass of 12.011 atomic mass units. All right. And I have just one carbon atom, right? So I am going to multiply the mass of one atom by the number of atoms I have. I'll write that out. All right, next is oxygen. So I go to my periodic table. I find oxygen right here. And if I look at its atomic mass, it's going to be 15.999 AMU or grams per mole. So like, okay, I take that information from my periodic table and I come back over here and it's 15.999 AMU. And now I'm going to multiply it by the number of oxygen atoms that I have, which is 2. So now what I'm going to do is I'm going to multiply these and then I'm going to take the sum of both. So 12.011 times 1 is just 12.011. 15.999 times 2 is 31.998. And if I add that to my 12.011, I will get a number. So I'm adding these two together. I get 44.009 atomic mass units. So this is the mass of one carbon dioxide molecule. It's also going to be the mass of a mole of them, or 6.022 times 10 to the 23rd. Ooh, it's such a mouthful. So this. So we will most likely, when we're doing calculations in lab, use the 44.009 grams per mole. But it's the same numeric value, just different units. Atomic mass units are much smaller than a gram. And so this is how you calculate it. We'll always walk you through this when we're going to be using it in any of our labs, or if we need to use it to understand a concept later on. I think the part of this that is the most important, though, is being able to read a chemical formula confidently and know what it means, the number of atoms, the types of atoms, what elements they are, and if it is something that's all a covalent molecule or an ionic compound.